When the sun sets, the forest belongs to the predators of the night. I'm Tobias, a biologist, and tonight I want to find out how these animals hunt and survive in the dark, and what happens when we, creatures of the daylight, step into their world. Okay guys, really quickly before it gets dark, why does night hunting exist? Well, actually about 2/3 of mammals are at least partly nocturnal, so it's pretty common. The night offers a lot of advantages. It offers less competition, it offers cover for both predators and prey, and also a change in abiotic factors, for example lower temperatures. You know, the separation of activity times we biologists like to call temporal niche partitioning, and it basically allows the different species to occupy the same space or even hunt for the same prey without getting into direct conflict. So when it comes to hearing, nocturnal predators also have amazing adaptations, with foxes, for example, that are able to rotate their ears and then pinpoint a sound source. They also then tend to have a different hearing range compared to us, with our upper limit at around 20 kilohertz and theirs at 60 kilohertz, which is a really big difference. Then also, if we look at owls, for example, some of them have asymmetrical ears, which means that on their head, one ear is higher than the other one, which allows them to vertically pinpoint the sound, which makes them really efficient at hunting in the dark. So there are many adaptations, and what I'm gonna try to do now is use what is called, a fox call, which is basically a whistle that imitates the sound of a wounded rabbit or a mouse. And I'll just try and see if I can attract the fox. By the way, this definitely sounds a bit funny, but I'm gonna give you a sample first of the rabbit, which sounds like this. And then also the mouse, which is much more, quiet, I guess. So what I'm going to do now is just do a couple of rounds and see if I can attract something. However, it is still pretty early, so yeah, I'll just see if we get lucky and I'll just give it a try. Okay guys, so it's a little bit later, the sun has gone down, so I'm gonna try a couple more calls and see if we can get something. For now it's been pretty it's been pretty unsuccessful, I would say. But yeah, let's keep going. Okay guys, I just moved to another spot. It's actually getting pretty dark now. I'm in the middle of a field. It should be prime time. I'm just gonna keep working the calls and I'll try and see if something moves. It's actually really cute. There are a couple of deer right on the forest edge. They're pretty far away. I'm gonna try and get them on camera. But yeah, that's super cool. However, at this point I was ready to call it a night. I was pretty sure every fox in the area was ignoring me on purpose. But then, just as I was about to leave, the darkness broke its silence. Okay guys, I think there's something moving. Yes, that's a red fox. Wow, gorgeous. I'm actually gonna try to get it on camera real quick. I guess it worked. I think it just really goes to show how great the hearing is. You know, I'm in an open field. He must have heard me from, well, definitely a couple of 100 meters away. You know, he was basically just there for a couple seconds and then gone. You know, I'm thinking he probably saw me because I'm sitting on a but on an elevated position right in the field. But yeah, amazing, wow. Okay guys, I'm just heading into the forest now. I'm really gonna try and just capture the sound atmosphere, because you know, the forest can really come to life at night and it sounds absolutely amazing. But yeah, I'm gonna go now and I'll try it and I'll capture it as well as possible. Oh wow, what was that? Definitely sounds like an owl. So I'm actually really enjoying the hike. It's really, really peaceful. If that's something you've never done before, I can highly recommend it. There's definitely really a lot going on tonight. It's pretty cold as well, but you know, that doesn't seem to stop the animals, I guess. Okay, I have no idea what that was. Definitely a bit scary. There's something really big out there, and I have no idea what it is. I'm still gonna check it out. So it started somewhere down here. Okay, I'm actually seeing a set of eyes in the distance. I have no idea what it is. Oh, you might be able to see them in the video. I'm flashing the light a bit so you can see the reflection. Okay, I'm gonna try and check it out what it is. I can definitely still see the eyes staring at me. Can you see the eyes? It's actually a deer. Oh wow, that was so pretty. Oh, that was pretty sweet. I don't know if you guys could see it in the video. I think it's actually still standing there. Wow, what a gorgeous animal. So for seeing in the dark, the goal is to capture as much light as possible, even if color is lost. These night vision goggles, for example, work by electronically amplifying faint light, so we as humans can see in the dark. Night-active species don't use electronics, but they use biology to do something similar. This is why many animals have large eyes and pupils, and also a high ratio of rod cells to cone cells. Rods detect dim light, cones detect color. To give you an example, humans have about 20 rods per cone, whereas owls can have more than 100. Another structural adaptation is the tapetum lucidum, a mirror-like layer behind the retina that reflects light back through the rods. It improves light capture by 30 to 50% and is what typically creates eye shine in many animals like cats, or this fox. However, in nature, there's usually a trade-off. When you're good at one thing, you're often not as good at another. For nocturnal predators, that means excellent low light sensitivity, but limited color perception and sharpness. For example, foxes see mostly in blues and greens, and reds look gray. Smell is another really important sense. Nocturnal predators show strong adaptations here. The olfactory bulb in a fox's brain is proportionally much larger than ours. It is used for hunting, communication, and orientation. Many nocturnal predators also wind hunt. They move crosswind, so scent blows toward them. Stealth and locomotion are another really interesting topic. Owls, for example, have specialized feathers that make flight extremely quiet. Foxes have soft padded feet for a silent approach, and a flexible spine with mobile shoulders that help with smooth, controlled steps and accurate pounces. Okay guys, I think that was it for today. It's actually getting pretty cold, so I'm gonna head home. I really tried to capture the sound atmosphere as much as possible and get some good shots with the camera, but it's a really dark night as well. But yeah, it was definitely fun, and I'll see you guys in a bit. Nocturnal predators are not only fascinating, they also play important ecological roles. They control rodent populations, helping keep crops and forests in balance. They shape prey behavior. An example of this is the ecology of fear. Let me know if you guys are interested in a video about this topic. And they move energy up the food web from insects and small mammals to higher trophic levels, which simply means an organism's feeding position. They are producers, herbivores, then predators. But light pollution is a growing pressure. It disrupts circadian rhythms, navigation, and hunting success. Many bats avoid lit areas, losing feeding zones. Some prey stay active longer, shifting food web timing. What helps is to use shielded, warmer, dimmer, and timed lights and maintain dark corridors and connected green spaces so nocturnal species can move and feed safely. Oh, finally, the city lights. Thanks for watching. I hope you learned something new about nocturnal predators and how they hunt and move in the dark. If you would like more science-based nature videos, there's a lot more to explore out there. And as always, stay wild.